This is a video for AQA Further Pure Mathematics. This is section 1.5 of the sequences and series, in which we're looking at the method of differences. The method of differences is one where we express a sum in a different form so that when we write it out, most of the terms will cancel in a regular pattern. Now this is often done by using algebraic identities. And as an example of that, I'm going to look at this identity, which is 1 over r times r plus 1 is the same as 1 over r minus 1 over r plus 1. So therefore, if we needed to find this sum, the general expression for this sum, instead of doing it as it stands, or trying to, we could say, well, this will be equal to the sum from r equals 1 up to n of 1 over r minus 1 over r plus 1. And now what we can do is say, well, what happens when we start putting r into this? So when r is equal to 1, we get 1 over 1, which is just 1, and then minus 1 over 1 plus 1 minus a half. When r is equal to 2, we get 1 over 2 and minus 1 over 3. And that pattern will continue. So the next one is 1 over 3 minus 1 over 4. And we can keep going now until we get to the penultimate term, which will be 1 over n minus 1 minus 1 over n, and the final term 1 over n minus 1 over n plus 1. Now if you look at what we've written down, you can see that a lot of these terms are going to cancel out. So the first bracket has got minus a half, but the second one plus a half. And then this keeps going, minus a third, plus a third, and so on. All the way through, the 1 over n minus 1 would have cancelled in the bracket before that. And then finally 1 over n minus 1 over n and plus 1 over n cancel out. So leaving us in the sum with just two terms. So that our sum is therefore equal to 1 and minus 1 over n plus 1. And of course they can be combined into a fraction with a single denominator of n plus 1. So we get n plus 1 minus 1, or just n over n plus 1. Now it's not always the consecutive terms that cancel out. So just to show you an example where it's slightly different, I'm going to look at this one, 1 over r and r plus 2. Now we can show that 1 over r and r plus 2 is the same as 1 half, and then 1 over r minus 1 over r plus 2. And therefore the sum of r equals 1 to n of 1 over r and r plus 2 must be the same as 1 half the sum from r equals 1 to n of 1 over r and minus 1 over r plus 2. Now again, we're going to take this a term at a time, leaving the half outside. The first term we get is 1 over 1, so just 1 minus 1 over 3. The next term is 1 over 2 minus 1 over 4. You can see nothing cancels there, but it's not until we come to the third term that we get then plus 1 over 3 and a minus 1 over 5. Now if we keep going, if I write down the terms towards the end, then they are as follows. 2 terms from the end will be 1 over n minus 2 and minus 1 over n. The penultimate term 1 over n minus 1 minus 1 over n plus 1, and then finally 1 over n minus 1 over n plus 2. Now we can look at what cancels out this time, and as I said before, it's not consecutive terms that cancel out, but we can certainly see that there is a lot that we could do. So we've got minus a third here, and then 2 brackets further on plus a third, and then obviously it's going to continue like that. Minus a quarter will cancel with the bracket after that, and the minus 1/5 will cancel with the bracket after that, and so on. And then when we come to the end of the expression, we can see there that the 1 over n minus 2 would have cancelled with 2 brackets before that, the 1 over n minus 1, and finally the negative 1 over n cancels with the 1 over n in that final bracket. So this time we've got 4 parts that are left: the 1.5 at the beginning of the expression, and at the end minus 1 over n plus 1 and minus 1 over n plus 2. So in total we get the following as our expression. Well, this needs to be written as a single fraction, so leaving the half outside that bracket for the moment, inside we're going to get a fraction where the common denominator is 2 multiplied by n plus 1 multiplied by n plus 2, so just taking the factors and multiplying them together. So then when we look at the expression, the first term is just going to be 2 n plus 1 n plus 2. The second term is plus n plus 1 and n plus 2, and then we're subtracting from that 2 multiplied by n plus 2, and finally subtracting 2 multiplied by n plus 1. So now multiplying out the brackets to give us the quadratics. The first one is 2 times n squared plus 3n plus 2. Then we've got n squared plus 3n plus 2, and then finally we've got then minus the 2 times n plus 2 and minus 2 times n plus 1, all divided by that denominator of 2 n plus 1 n plus 2. Well, if you look what we've got on the top line, in terms of n squareds, totaling them up, we've got 2n squared plus n squared, 3n squared. So 3n squared. And then looking at n's from the first bracket, that's 6n. And then 3n, so that's a total of 9n. But we're subtracting from that a total of 4n, so we've got plus 5n. If we look at the number term, it's 4 and 2 is 6 from the first 2 brackets, and then subtracting 4 and subtracting 2, so the number term disappears. So we end up with 3n squared plus 5n on the top line, and then 2 times n plus 1 and n plus 2 as the denominator. So we could then factorize out the n on the top line to give us n times 3n plus 5. And on the bottom we've got then 4 times n plus 1 and n plus 2. Well, that's the end of this video on the method of differences, and it completes the sequences and series section 1.